off with just a little bit of focusing in on some of that notation again, making sure we're naming lines and segments and rays correctly. This focuses in on some of the very common mistakes that I see. So the first question, we're essentially matching these to these. Some of these make no sense and we will straight up cross them off. But that's our goal, is to match. First thing I see is FG. Is that a line, array, or a segment? There's no arrows. That's a segment. Segments are named like that. Okay. So I'm looking for the segment FG. A, B, C, D, or E. What are we thinking? Okay, I heard a couple different things. I heard A, I heard C. I would agree that A and C are segments. Beautiful. I want segment FG. To name a segment, the two letters have to be at the far ends. Is the first one FG? No. Is this one FG? Yes, because it starts and ends at F and G. And we might use some of these multiple times, by the way. Okay, next problem, also FG, but is this a line, a segment, or a array? This one's a line, it's got the line above it. It's got the arrows. So now I'm looking for something that's got arrows going both ways. D's got an arrow going one way, B's got an arrow going both ways. Do any of the others have arrows going both ways? No, that's the only line. Can I call that line FG? Yes. To name a line, the two letters just have to be points on it. Are F and G both on that line? Yep, then that works fine. Next one's FGH. It's got a segment symbol. It's got 3 letters. That's different from the previous 2. How many letters should we put in a segment name? 2. Cross it off. That one's there as a common mistake that people make. No 3 letters allowed. Not for segments anyway. Some things are 3 letters, not segments. Okay. HG. Line, segment, array. Ray, it's got 1 arrow. Okay. Now when it comes to our rays, remember the first letter has to be the end point. So the first letter should not have the arrow on it. So if it's HG, these are my 2 rays pictured. The first letter's H. Which of these starts at H? Nobody's home. This is Miss Benson. If he's in my first hour, yes, I'm still learning names. Yes, I do. Right now. Okay. Yep. Sounds good. Bye. I would guess as much. Okay. Okay, so back to this. H, G. Again, the first letter is the end point, so the first letter is where it starts. Which of these two starts at H? E. H is a point here. On this one, H goes towards the arrow. So, E. Okay, question 5. Line, segment, array. Segment. No arrows. F and H have to be somewhere on it, or do they have to be at the ends? For a segment, they have to be at the ends. F and H at the ends? A, because there's no arrows, and those are at the ends. Okay. Line, F, G, H. Three letters?
Yeah, 3 cross.
Do you use 3 for a line? No. Cross it off. FH. That's a line. B. Yep. When it comes to lines, the 2 letters have to be on there somewhere. Who's got an alarm that sounds like a legit alarm?
Oh, that's me.
Can you turn it off? Because I don't know which one it is. It's not loud, but I can hear it. Thank you. It's okay. Okay, last one. HF. 1 arrow means it's a ray. And if it's HF, it has to start at H. Which ray starts at H? E. This could be called HF. It could be called HG. We used it twice. We didn't use D at all. Now, when it comes to this, one of the things that you're going to notice is we're also going to notice that the lines and the points and the rays end up hitting one another. When you have things that hit one another, the set of the points that those 2 or more figures have in common, the points that they share, are called the intersection. Now, this word probably isn't overly scary to you because you've probably heard of intersect before. Heck, you've probably heard of intersection before. Typically with driving, but so, given the diagram, highlight the intersection. Now, you can use a highlighter if you have one, or you can just draw on it somewhere. So I've got 2 lines right here. Where are those 2 lines hitting one another?
In the middle.
At the intersection in the middle. Is this thing right here a point, a line, or a plane? Point. 2 lines, if they intersect, will always be intersecting at a point. They cannot intersect creating a line. They cannot intersect creating a plane. They can only intersect creating a point. Okay. Now I've got a plane and a line. Where do they appear to be hitting one another? Or top and bottom? Not quite. Remember we talked about the dotted? What did the dotted line mean?
3. There are stuff behind that.
It was hidden behind. Where it hits, it wasn't behind, it wasn't behind, it wasn't behind, all of a sudden it's behind. How does something go from not being behind to being behind it in the middle of it?
Because it goes through.
It had to stab through the middle of it, which means the intersection is where the line goes from being able to be seen to where you can't see it. This right here is the intersection point. And again, it is a point. The last picture that we've got here is two planes that are intersecting. You've got two flat sheets of paper essentially hitting one another. And you have two flat sheets of paper hitting one another, creating a picture that looks like that. The intersection is where they touch. Where do these two note cards touch one another? Middle, all the way along this. Now planes go on forever, which means this intersection goes on forever. What is a straight thing that goes on indefinitely? A line. Two planes, when they intersect here, and they create a line. So, last thing you're gonna see is just a couple more examples that this time focus on the stuff we did yesterday as well as a little bit about intersection. So we got this picture here. First thing it asks is, what are the names of the two planes in the picture? Now, if you're not 100% sure how to name something, remember, go back to your notes as necessary. Planes can be named by a single letter, as long as it's a capital letter in the corner, or planes can be named by 3 points that are on the plane. Do you see the two planes in this picture? I'm going to talk about this one first. Does that plane have 3 points on it? Does it have 3 dots on it? No, it's only got 1 dot on it, so I can't name it that way. Does it have a capital letter in the corner?
Yeah.
What letter?
B.
Plane B. This is the other plane. Does it have 3 points on it?
Yes.
But are they all on the same line? Yeah, so that doesn't do us any good. So instead, because those 3 points cannot be on the same line, instead we look for the capital letter in the corner. Is there one?
Yeah.
What letter?
A.
Plain A. Name the intersection of the two planes pictured. When two planes hit one another, they intersect at what? What shape? A point, a line, or a plane? Had to hit one another at a line. Do you see the line where the two planes hit?
Yeah.
It's got the M on it, but can you name a plane by 1 capital letter? Or sorry, a line by 1 capital letter? Mm-mm. Lines can either be named by a lowercase letter that's by the arrow or by 2 points on it. Does this line have 2 points on it?
No.
No. Does it have a cap or a lowercase letter by its arrow?
Yes.
What letter?
K.
K. Line, and it's a lowercase k. Explain why part of PQ is dashed.
Because it goes behind.
Because it goes behind. What's it hiding behind?
The other plane.
Is it plane A it's behind or plane B? Plane B. It's behind plane B because it's just this small part of B that it's dotted on. It's sitting on top of A. Give one name for each line shown. Now we already talked about one of the lines. We called it line K. That was that one. What can I name this line?
LAQ.
Nope. A isn't on it. Plus, how many letters do I need for naming a line? If I'm going to name it by its points, I need 2. MP would be one option. Are there other options? QM, QP, PQ. I'm just gonna write NQ. What symbol do I put above it?
The line.
The line with or without arrows?
With arrows.
With arrows. Okay, is there another line in this picture?
That's one.
XY. Does the line PQ intersect plane B? Intersect means hit, means runs into. Does this line hit this plane? Okay, that's the first part of the question. Then it says, if so, name the intersection. Where does it hit it? Point M. Remember, K is, it's hard to tell with K's. K is a lowercase letter, though, by the arrow. The point is the point M. Now, the last question on here is to push your mind a little bit. The last question on here, people get both right and wrong all the time. And it's because of something we haven't talked about yet. It says, does the line XY intersect the line PQ?
No.
Does it appear to in the picture?
No.
No. But do lines stop or go on forever? Go on forever. If I extend this one a little bit further and extend this one a little bit further, do they look like they might meet?
Yes.
They look like they might, but it's not necessarily true. Here is a type of question I would never put on a test or a quiz. Like I said, I'm just trying to push you a little bit. These planes are sitting like this, right? They're intersecting one another. And then we get the line XY. Is the line XY on either of those planes or is it above them? It's above. Would it be like here? Or if you're looking at it straight on, could it be all the way back here? Could it be over here? Can you tell when you're looking straight on how deep it is?
It looks like it's in the distance.
Looks like it could be in the distance, but it's hard to tell with a line. One of the things that happens, and again, this is me giving you something as an expansion. You don't have to memorize this, but I think it's good for us to talk about. Two lines that look like they might meet, but are in 3 dimensions, may not. Think about when you're looking at a picture. Okay, I'm looking at a picture. There's my picture. There's this country road going down these hills. I know, it's great. Along the sides of the road, there's the power lines, all that wonderfulness. And then there's this tree here. I know, I'm a great artist. Now, I just drew the tree directly over the power line. Does that mean the tree and the power line are in the same spot? No. One might be deeper than the other. In geometry, when you've got lines that look straight on like they're intersecting, but from the side, all of a sudden you notice they're not, it's called skew. It's not something I'm testing you on. But I do like to question it because the answer to this is maybe. We can't tell. If you see a picture that has planes on it, in other words, it's 3 dimensions, but you can't tell, you cannot guarantee that things intersect. If you see a picture that doesn't have planes on it like this, you can assume they intersect. Again, am I going to put a question like that on a test or a quiz? Absolutely not. I am not trying to trick you, but I think it's important to talk about. Okay, That's enough of me talking. Today we finished up 1.1. It's Tuesday, so our homework's due on Thursday. Remember, on your homework assignments that you do in your book, please write the title of the assignment, which yesterday was page 8, day 1. Today is page 8, day 2. Today's homework includes questions 25 through 34 and then 41 through 44. You got a chunk of work time, take advantage of it, please.